C'est toi qui parles sur les slides? Oui, donc tu devrais pouvoir prendre des notes. T'as la main avec ton beater.
Good morning. Oh, welcome to Chicago. We are going to start very soon, so if you can maybe sit down for those who aren't yet, it would be nice.
Jeff, many seats on the counter. You don't look that bad.
Okay, let's start. So this is Bess. The usual note that I'm sure most of you are already aware of. So you need to be aware of all these rules and well, follow them. Please read the documents if you haven't yet. The blue sheet. Would someone be happy to be the Jabber relay, Jabber scribe? Would someone do that? We can possibly do without. I don't know how many people are on Jabber anyway. But if people want to take a minute to complement the one that we will take, that would be appreciated as well. Would somebody volunteer for minutes? Okay, thank you. So since last IETF, we made a few working group last calls for these three documents: EVPN DCI overlay, EVPN inter-subnet forwarding, and EVPN prefix advertisements. Those three are pending conclusions. We need authors to integrate the feedback provided during the working group last call. Since last IETF, something that I didn't mention. If you want to comment on these slides, go to the mic and you can do it. We have time this morning. Since last IETF, we also adopted two new working group documents: EVPN IGMP MLD proxying and the BGP control plane for NSH service function chaining. Two other things were done during this cycle. One document is back to the working group, and it's been revived with a new editor. It's the BGP signal and system IPVPN draft. So we will have to move this one forward as soon as the documents that weren't addressed yet become addressed. And the last point worth mentioning is the MVPN MIB work that's been finalized at last. So we want to thank Hiroshi Tsunoda who took over the work. So something that we want to also mention is that we went through the process of asking IANA for early allocations of EVPN route types for 2 drafts. This is something that that is better done the earlier the better. We will do it also for the IGMP-MLD proxying draft. So this is a particular case of an IANA registry which has to go through this process. But many of the registries related to RFCs of the working group are actually first come first serve registries, and in these first come first serve registries, draft authors can directly request IDs from IANA by themselves. So this is something that you need to be aware of, and you can actually use a form provided by IANA for this. It's good if you make the working group aware of this kind of request that you would do to IANA, but well, you have to keep in mind that it's a lightweight process, and again, the earlier the better. It avoids all kind of messy stuff that we need to do if people end up using the same IDs. So today we'll start by a status on a working group document on Yang, follow with a bunch of EVPN drafts, and then close the session with a multicast and multicast VPN drafts, one on Yang and one on a general purpose BGP multicast. So Patrice, it's up to you now. What do you mean by wrong?
Yeah.
Closer.
Better? Good. All right, good morning. I'm Patrice from Cisco. Just here, quick update on the Yang for this morning. The 3 guys, the L2, EVPN, and L3. For the L2 VPN, oops, projector, just a second. No? Okay. All right, but I cannot read. I'm kidding. I know. All right.
Give me, we have time. Give me a second to try to.
Yeah, we are not in a rush this morning. We should be done far before the end of the slot. So we have time to tweak a bit with the hardware. Non, aucun Bluetooth. C'est ça. Entre les deux, peut-être. Ok. Oh, nickel.
Thank you. All right. For the L2 VPN Yang model, if you look at the latest version, which is I think 0.5, thanks Imanshu for 0.5. So there's been a big rework. We simplify a lot the endpoints. The Yang has been shrinked also. It's much more smooth, clean, and so on. A big thanks to Jal Heron because he'd been on with us and helping to simplify what we have in mind there. So have a look, it's much better. So the endpoint, yeah, as I said, it was consolidated. And also we, there was, I think, a discussion with AC, right, about the BGP common parameter. So we want also that all the Yangs follow the same kind of model because what happens is we were redefining stuff that was already defined in the routing area. So we've been reusing that. What is next from us, and it will happen this week? That's what we said among ourselves, is we're going to close with RRB. So we want to make sure that the RRB functionality is added, and also we want to close on the relationship between the EVPN Yang and the LTVPN Yang. On the EVPN front, same thing for the BGP Yang. All right, so we use what routing has been defined. So we also make a few corrections to the Ethernet segment for allowing more than one AC or more than one TOR to be used. Couple more stuff on the DF prediction algorithm, and I think we're going to need a further extension because of the new draft that we are presenting today. So that will happen. And for this week, the big task, or how do we define the EVPN VPWS? So we already started to talk about it, but we not able to close that one. Same for RRB, and same for the flexible cross-connect service. These three things as, anyway, we need to close that this week. My objective is L2VPN and EVPN should be fairly completed on Friday. So stay tuned. We're gonna most likely we're gonna post a new revision this week.
We had a comment, Patrice. Our recollection was that it was decided to wait for flexible cross-connect to be adopted as a working group document before we integrate it into the Yang model.
Okay. So what we'll do is we'll make a suggestion on how it can be done, right? And whenever FXC is getting accepted, then the Yang will be ready. Okay? Is it better that way? All right. Also, we got a lot of comments this, I think last week on the email regarding our Yang model. We're going to address that also this week. I personally didn't have time. So most likely people who had a question, I know John, I think, has some question as well on the Yang. Don't worry, guys. It's not I'm ignoring you. They're going to get addressed this week. On the L3VPN, there's not much. I know the draft has expired. We'll make sure that we can make it alive again. Most likely, we'll just put the common BGP Yang, the routing stuff that I talked previously. So that's pretty much it. Is there any questions? So guys, if you have questions or you have comments, please get in touch with us this week. Again, we're going to do a lot of work, especially tomorrow, and also maybe on Thursday. So please get in touch if you have questions. All right. Thank you.
Okay, so no comments on the draft, I guess? These drafts? So next speaker is Jorge.
Short it down, Patrice. Morning, everyone. This is Jorge Rodan, Nokia. So first one is going to be pretty short. It's a short update, but significant. That's why we thought it was good to bring it up. So this draft is optimized Ingress application. And as a short refresh, it's covering two aspects. The first one is the pruned flood lists. That's basically a way to prune non-interested MVEs from the broadcast, multicast, and unknown flooding lists. And the second aspect is the assisted replication. That is a way to optimize. So when you have IP tunnels and you don't want to use multicast in the underlay, this is a way to optimize ingress replication. So you basically, when you need to send broadcast multicast, instead of doing ingress replication, you send it to an AR, an assisted replicator, and that AR sends the content back to the rest of the nodes. So here there are two ways: the non-selective AR and the selective AR. So we've made a few changes here on the selective AR, and simple but significant. So basically what we've done is to replace one of the routes that we were using. We are now using the leaf AD route, replacing the leaf AR route that we used to use from the leaf nodes. So the leaf AD route is route type 11, has been allocated already by IANA, and is defined in the BOM procedure updates draft. And it's really a natural way to do it. So basically, when you when the replicator sends a route with seeking for explicit tracking, a natural way to reply to that tracking is to use a leaf AD route. That's what happens in MVPN and also in EVPN for other procedures. So we thought it was a natural way to resolve this. That's why we replaced the route. And besides that, we've incorporated the IANA allocated code points for the PMSI tunnel type and the flags. And we added some clarification on the EVPN multi-domain split horizon, especially after talking to Jeffrey and some others. And well, that's basically the explaining the selective assisted replication procedures. And basically what we changed is here this route. So when we get from the assisted replication node, we get this IMET route with the leaf required flag set. We reply with a leaf AD route. And with that route, basically the replicator is actually able to build the leaf set, and details in the draft. So basically, this draft has some vendor implementations. It's being implemented, deployed, and we seek for more working group feedback. And it's, if not ready, it's close to be ready for working group last call. Are there any questions?
Okay, so we understand that this document is quite mature now, so we will likely do a working group last call very soon.
So next one is called EVPN path attribute propagation. This is draft 00. And basically what and why. The idea is that in EVPN, we have some, we have the ability to advertise IPv4 and IPv6 prefixes in two route types. Route type 2 for host routes, and route type 5 for prefixes. So the issue that we are trying to address here is that when you have EVPN tenant domains and you need to extend those to the WAN and other admin domains using other SAFIs, you need to define the interaction between the EVPN route types 2 and 5 and those other SAFIs, right? The normal example is when you have in a data center routes type 2 and 5, distributing prefixes, and you need to actually install those in an IPVerf and to regenerate the routes in IPVPN, right? So we are trying to, in this version, basically is just a rough description of some identified use cases and some of the potential solutions, but at this moment it's pretty open. We really think the working group feedback is key for this work to progress. Some of the use cases we identified are the following. So this is the first one. The idea is that you have certain data centers, EVPN data centers, that are part of the same admin domain, and they are interconnected by an IPVPN, which is part of a different admin domain. So the IP prefixes are originated by EVPN and are somehow terminated on the MVEs by EVPN as well. But in between, you have a different SAFI. So here, the idea is that you may have two different options that you want to implement. The first one is you don't want to propagate any attributes. What that means is that if you receive an EVPN route here with some communities, local preference, and other path attributes, you actually install the route, you regenerate the IPVPN route, and you reset all the attributes. So you re-originate all the attributes so you don't propagate them, right? So the EVPN network behaves as this abstract CE domain. So that's one option, but the other option that you want to implement in some cases is that here at the receiving MVE or P, you really want to have the original attributes that the advertising MVE intended to add to the route. You don't want to lose them for the BGP path selection at the terminating MVE. So in that case, you may want to do this tunnel mode. So you want to somehow tunnel the EVPN attributes between the data center gateways so that all the attributes are actually available for the terminating MVE. So those are the two options that we identified. Another different example is when you have data centers or EVPN networks, right? And again, you have the gateway receiving those EVPN routes, and you need to re-advertise those in IPVPN. And actually, the P receiving those routes, well, you may or you may not want to propagate the attributes, right? So in this case, the IP prefix that you originate and receive, they are in a different family, not in the same family as in the previous example. Same thing here, but instead of IPVPN, you can use just SAFI1, right? So IP. So here we identified two different type of behaviors. So option one could be the no propagation mode. Again, that means that you regenerate the prefixes without the original attributes. But option two could be a uniform mode of propagation. So that means the commonly used attributes between the two families, you may want to propagate them at the gateways, right? So that at P1, you actually you don't lose all the path attribute information when you make a BGP selection. So, but this is really an open discussion. We really want to thank Eric for the initial feedback. But there are a lot of aspects to discuss and to include, hopefully. So one aspect is to define the general architectural models. Another aspect is to define what to do when you have multiple families in the same VRF, what RDs and RTs you use. The other aspect is how do you tunnel the attributes. Right now in the draft, there is an initial proposal based on RFC 6368 and the ATT set attribute. But, well, that's the initial proposal. And the other point is for the uniform mode of propagation. So what kind of attributes you want to propagate, or what attributes are forbidden to propagate. Another aspect is what if you have aggregation of host routes and you still want to propagate attributes? And some of the things are, what if you receive the same prefix via EVPN and IPVPN? What is the path selection rules in that case? And etc. We are also looking for some of the use cases where this can be useful. And so that's pretty much it for this draft. So we really want to have working group feedback for this draft.
Alice, address this Cisco system. We have there is another draft, EVPN, IPVPN, interrupt, and some of the use cases may overlap with these other drafts. So I think we need to make sure that minimize the overlap and so that we avoid any duplication.
Sure. Yeah, we need to discuss about that. Yeah.
Okay, no other comments. Just to have an idea, can you please hold your hand if you have read the document? Okay, thank you.
All right, so last one but not least, the preference-based EVP and DF election draft, version 2. So short refresh, this draft was about having a deterministic DF election mechanism for EVPN. So in other words, so what we were trying to address is the following requirements. So we wanted to have an admin preference value that you can configure and control on a per P per Ethernet segment basis. And based on that admin preference value, you can actually select a DF. By default, the highest value wins. And but you can also preempt the DF at any moment in time. Let's say, in this case, if P1 has the highest preference value for the blue Ethernet segment, at any time you can actually change the preference in P2, have a greater preference value, and P2 can actually take over. So this is needed for operations and maintenance of the network and stuff like that. And then the third aspect that we wanted to tackle is the non-revertive operation. So in the DF election, so when the DF goes down, you get a hit on the traffic. When the former DF goes or comes back up, you get a second hit, right? So in some cases, you don't want to, you really want to avoid the second hit because it's not needed, right? So this is basically what the draft is about. And so the changes in revision 2 is about the non-revertive behavior. So in revision 1, the assumption was that all the EVIs or ISITs that you had in the Ethernet segment, they were using the highest preference value, which is the default one. But obviously, if you want some load balancing on regular Ethernet segments where you have multiple EVIs or multiple ISITs, what you want to do, or what the draft is suggesting, is that you can have some ranges configured. For instance, you can define that from EVI 1 to 2000, you use the high preference value, whereas from 2001 to 4000, you use the low preference value. So in that case, you get some load balancing of the TF. Now, the non-revertive behavior, of course, must deal with both cases. So you need to avoid the second hit, not only for the EVIs using the high preference value, but also for the ones using the low preference value. So, and this is what we've changed in the second revision of the draft. So a simple example is, in this case, you have 3 Ps in the same blue Ethernet segment. The idea is that you have multiple EVIs. And for instance, EVI 1 is using the highest preference, and EVI 2 is using the lowest. So the way it works is basically when, based on the preference values, P3 was the DF for EVI 1, and P1 is the DF for EVI 2. Now, if P3 goes down, P2 takes over for EVI 1, right? And P1 is still the TF for EVI 2. Now, what happens when the P3 recovers? So when it comes back up, basically P3 waits for the boot timer. So that's some time that is giving P3 some time to collect, to gather all the routes, all the ES routes, and to see the different preferences. Now, what P3 does next is actually it computes the highest P and the lowest P. So the highest P is the P that advertised the highest preference, and the same thing for the lowest preference. So so once P3 has computed those two Ps, so for instance, the highest P is P2 and the lowest P is P1, P3 will compare its own admin preference with those two Ps. And what happens is, if P3 admin preference is greater than the highest, basically P3 will advertise an ES route with preference equal the highest P and the DP bit 0. So that is not actually making any changes in the DF election on P1 and P2. Because, well, if you read the draft, you will see that if the preference values are the same, the DP bit is the tiebreaker, so P2 still remains the DF. So there is no change. So if P3 admin preference had been lower than 100, basically P3 would have advertised an ES route with preference 100 and DP 0. And that wouldn't have created any changes or made any changes in the DF on the other Ps. So basically, this is how it works. And P3 will not change again to its admin preference in the ES route until the current DF basically goes down. So that's the idea. This draft has vendor implementations. It's being deployed in service provider networks, and we really want to request a call for working group adoption.
Jeff, I apologize, I have not read the draft, but looking at your last slide reminds me of VRRP quite a bit. Have the authors discussed what happens when there's a routing partition in the AS? Because in such cases, the DF election itself may be, from the perspective of the different actors, not what you expect it to be.
The partition of the...
So the idea
Yes.
here is you have PE1, 2, and 3, which are probably communicating through a route reflector if they're not directly meshed. Directly meshed solves this problem a little bit, but in the case of one or more route reflectors, the DF election may be inconsistent between the different PEs, and in which case you get up interesting porting. I'm not saying you have a solution, I'm just asking if you talked about it.
That's, well, I mean, that is not, this is not only an issue in here. So if you have a partition, it's really affects all the DF election, all the different types that we have, right?
Mm-hmm.
So
It's just the fact that the reverted behavior seems like it's a newer thing.
well, it's a newer thing, and in the sense that we are not going back to the previous situation, but I mean, there is no change in terms of what if the ES routes, they don't get to the intended P and all that. That is common across all the different DF elections, right?
I am aware of that. This just seems to be making it one step more interesting.
Yeah. I mean, I don't. Obviously, you always have like redundancy and all that, and route reflector redundancy, and what you can do if you. I mean, if you have this split brain or whatever, I mean, it could be a matter of local implementation, or we can think about a solution or a behavior. But again, it's common to all the different DF elections, and we already have the base one, HRW. We have preference based, and some others coming.
Yes, I do realize this is not a new situation. I don't regularly call the working group to a high degree. Otherwise, I would mention this some time ago. But again, this is sort of adding another layer on top of that. So my question was, have you thought about it? It sounds like you're aware of it. You have not thought about what to do about it.
I think we all have thought about it in our own implementations, and we know pretty much, or we have a deterministic way of behaving in that case. But I don't know if we need an interrupt solution for that case. Maybe we do. Maybe, I don't know. Okay, thank you.
Other comments? I do have one, in fact. Having range configured means that if you want to benefit from this load balancing, you have to allocate EVIs in a way that's consistent with the ranges allocated. If you only use the first ones, you won't have any load balancing, right?
Yeah, so the draft says, but by default, you use the highest preference value, right? So obviously, if that is the case and you have multiple EVIs, you don't have any load balancing. So if you want load balancing, you need to define a range of EVIs using lowest value. And that has to be consistent in all the P's in the ES.
So my question is, why not use a modulo-based mechanism? For instance, all the even EVIs would have a given PE at the highest preference, and the odd ones would have the other one with the highest. And if you have more than 2 PE, then you would have a modulo-based, a modulo 3-based repartition.
It's okay as long as you don't change the high or low for a given EVI depending on the number of P's.
Yeah.
Right. So otherwise, you go back to all the issues that we have in RFC 7432 with the TF election and the modulo.
Yeah. So you have to rely on something that's consistently configured.
Yeah. So that's the key. It has to be consistently configured in all the P's in the ES. I don't see a reason why not. Yeah, as long as an EVI is consistently configured, yeah, that might be an option.
Mm-hmm.
But usually, if you really want to have control, which is the main goal here, that's why you configure the preference. You normally just configure the ranges, or you add a knob saying, okay, even EVIs, high, out.
Yeah. Control is an element, but it's also important to have good load balancing. And if to obtain good load balancing, you have to allocate the IDs in a way that's consistent with whatever has been configured for preference-based DF election, then that can be a constraint as well, maybe.
That's possible. We can add a paragraph or something. Yeah. Okay. Thank you.
Yeah, just one more question. Sorry, this one, Cisco. This mechanism, does it work also on gateways, BCI?
On where?
On the BCI? Have you thought about it?
Yeah, well, I don't see a reason why it shouldn't. Yeah. I mean, let's
talk about it.
Okay. You see any issues? All right. Thanks. Thank you.
Thank you, Jorge. Yeah, so you were requesting a code for working group adoption in your last slide. So just to have an idea of what the room's feeling, can you raise your hand if you think this document would be suitable for adoption? Please raise your hand if you think it's not suitable for adoption. Thank you. Next speaker is Ali. Non, c'est phase DF recovery. Do you know jokes? You can tell one. Sure. Next time then.
Next time, yeah.
Make sure it's in the minutes.
Okay.
Because of the resolution
Very good. This is a draft that discusses incremental improvement for our DF election. And this is especially with respect to the, when you insert a new DF, when you insert a new PE, or when a failed PE is recovered, how are we going to improve the recovery time? So if we go back to the RFC 7432, it describes baseline DF election procedure that is based on the VLAN carving. And there is a draft IETF Bess EVPN DF election, which talks about how we can improve that VLAN carving such that when PE recovers, you don't shuffle the VLANs, and some of the VLANs that are not impacted by the failure, we don't have to activate, deactivate them on different PEs. And it suggests HRW algorithm, highest random weight, for doing that. This draft is built on top of that improvement, incremental improvement, and it is a further improvement. It says, okay, now that we have the HRW algorithm and we avoid VLAN shuffling, let's also improve the recovery time and make it faster. So the current DF election, even with the HRW algorithm, it errs on the side of the transient black holing as opposed to the transient duplication. It should say duplication because most often it's going to be duplication and not the loop. In a very rare situation, we're going to have loop. The recovered DF lets all other PE know that it has joined the multi-homing group, and it starts a 3-second timer before doing the DF election. And that timer, if it is too short, then there is a possibility of transient duplication. But the 3 seconds timer is assumed to be long enough that all the PEs in the redundancy group can discover among themselves, and they do the activation of the service instance or VLAN on that Ethernet segment. And because the existing PE, upon receiving these Ethernet segment route from the inserted new PE or the recovered PE, they're gonna go and program their, they're gonna execute their HRW algorithm, and they're gonna program the blocking or forwarding for that VLANs. And because new PE got inserted, they're going to be blocking it. And after the 3 seconds timer, the new PE is going to put itself in a forwarding mode for those VLAN, and that difference in time is going to result in the transient packet loss or black holing that we're calling. So instead of waiting for that 3 seconds and going active, question is, can we reduce that and improve the recovery time further? And in this draft, there are 2 proposals for doing that. One is the handshaking between the inserted or new PE with the other PEs in the redundancy group. And the other one is assumes that all the PEs, they're running time synchronization, and we've seen it in some data centers that is the case. And when there's a clock synchronization among the PEs, it can be even, the handshaking can be even made simpler, and it can be unidirectional, and the recovery time can be even be faster. So one of the two approaches, if there is clock synchronization, you go with the approach number 2. If there is no clock synchronization among the PEs, you use approach number 1. So with the handshake mechanism, the recovered or new PE advertises ES route, and it starts the wait timer as before. And all other PEs in the redundancy group, when they receive these ES route, they're going to run their HR algorithm for the DF election again as before. So the first 2 bullets, it is based on the RFC 7432 and the DF election draft. What we do is the 3rd bullet is suggested in this draft, that the PEs in the redundancy group that are capable of doing this handshaking, they do the next few steps. The inserted or the new PE sends a DF request to the previously inserted PEs or the existing PE in the redundancy group. And when the other PEs receive these DF requests, they're going to go ahead and program their hardware to block the VLANs, and they're going to send the ACK back. Okay, so when the inserted PE receives that, or the recovered PE receives that ACK back, it doesn't wait for that 3 seconds timer expire. It just go ahead and puts those VLANs in the forwarding state. So that's the difference in the receive of the ACK from the other PEs, to say that, you know, you can go ahead and put your VLANs in the forwarding state as opposed to waiting for that timer to expire. And the inserted PE, once it receives that, it puts it in the forwarding state, and there we go. Couple of things to mention in here. This handshaking is not on a per service instance or on a per VLAN basis. It is on a per PE basis. So regardless of the number of the service instances you have on that Ethernet segment, whether it is 1,000, 5,000, 10,000, you only send a single message per PE. So in case of there is like a you have a new PE gets inserted in a redundancy group that already has 2 other PEs, that new PE sends only 2 other messages. Only send 2 messages. So that's an example that we talked about, that PE1 and PE2 are the existing PE, and PE3 gets inserted, or PE3 is a recovered PE, and it sends a ES route to the PE 1 and 2, and then after that it sends a DF request. And once PE1 and PE2 receive that DF request, they block their VLANs and send a response back. And when PE3 at the time T3 receives that response, it goes and puts its VLAN in the forwarding state. 2 messages are being defined for one for the handshake request, one for the handshake response. These are the preliminary message format, and we already identified that there needs to be some minor changes. So before going to the time synchronization mechanism, let me stop here. It seems like there is a question.
Yes, Tony P. Juniper. Hey, Ali. So,
Hi.
yeah, interesting. So that's basically beginning of the Paxos protocol. So first, I understand correctly, you have to get all the acts, right, before you kill the timer.
No, you don't. You just, it works on a one-by-one basis. As soon as you get the first act, Okay, the handshake is on a per PE basis. So once I get a ACK back from you, I'm gonna just go and put the VLANs, which got, which you were the owner of it.
Also it does the VLANs at this specific.
Exactly.
region. Okay, fine. So that all will work fine as long as you, if you lose X, it's okay. You just run the 3 seconds.
Right.
There will be a problem with this 1 byte if you misorder X or if you run over this 1 byte. The guy coming up, there may be X in flight. There is all kind of interesting scenarios there. So that would need thinking through. It looks to me like it's basically the beginning of the Paxos protocol. Right?
No, Paxos is actually a lot more complicated. This is a very simple handshake.
That's why I said beginning, right?
Yeah,
Because
this is
all the
very
Paxos
simple
starts
handshake.
when the X start to get misordered, lost in flight, and so on.
So this is like a, every, there is a sequence number to making sure that there is no ambiguity.
Yes, I saw that.
And we are basically, in worst come to worst, in case there is a loss and all that, it defaults back to the
The 3 seconds.
3 seconds time.
Okay, I'll read the stuff and I'll comment on the
Sounds
list.
good.
Thanks a lot.
Okay, thank you. Are you all right?
Jorge Rodan, Nokia. Yeah, good draft. Couple of, yeah, well, I have a similar question. Just like Tony, I had some doubts,
Okay.
but you clarified. So 2 more comments. So first one, in the routes themselves, I think we need an originating IP, right, for the inter-AS?
That is exactly the same comment that John gave me, and you're right, we do, and that's what I said, we need to change these. So it's going to get reflected in the next next revision.
Okay. One more.
Just like for the Ethernet segment route, we have the originator IP address for the same reason.
Yeah, absolutely. When do you see a P sending a NAC? NAC.
So the
So there's an explicit NAC flag in the draft, right?
right. So the ACK is clear when it's going to send
Yeah.
ACK. Okay.
That's right.
The NAC is the exact use case is escaping my mind right now. So
No worries.
either if there is no clear use case, so then there's not going to be a NAC.
No worries. We can discuss later.
Yeah.
And yeah, also there is a flag that says init, but it's not really explained.
No, that needs to be removed.
Okay.
There is no, that flag is not needed, it's left over.
All right. And the last one. So in the diagram that you showed, there is
Right.
no way you can have a loop, right? It's when you have 2 CEs connected to the same.
Very
pair.
good. If you're talking about only a single failure, there is no possibility of loop because we have this ESI label that we send it even for the single active besides all active, and we ensure that the label prevents loop. The only time that's what I say in a rare situation, the only time you have double failure that you have 2 sets of Ethernet segment and the failure happens simultaneously or almost simultaneously at the same time, and the loop is through the network, and that is extremely rare situation.
I fully agree with you, but reading the draft, one gets the impression that
I think you're
have
right.
the same chances of getting duplicate as
You-
loop.
You are absolutely right. That needs to be clarified because we don't want to give a false or improper impression that there can be a loop, especially with EVPN that we went extra mile to make sure that there is no loop. So that needs to be, the text needs to be updated to make sure that it is very clear. The main scenario is duplication, and loop is under very rare situation.
Fully agree. Thank you.
And you had some other comments with respect to the how it's going to interoperate. with the preference DF election and how it's going to interrupt, how we're going to, we have these different variety, and those has been addressed, and we can discuss it offline.
Yeah, yeah. need to do
Okay.
that. Thank
Sounds
you.
good. Oh. Okay. So the second,
I'm sorry. Yeah, go ahead.
this is the second part of it. Hopefully we have enough time, right?
We do.
All right. So this is one of the rare situations I don't get rushed. So the second part is of this draft, or the second approach is says if we have clock synchronization, what we're gonna do, and the bidirectional handshake is not even needed in such situation. And basically, the idea in here is when you insert the new PE or the recovered PE, the recovered PE comes and says, okay, I'm going to start my 3 seconds timer, and I'm going to indicate that instead of wait till the duration of these 3 seconds and take over my VLANs that I own, I'm going to indicate 1.4 seconds from now that I'm going to take ownership of these VLANs. And I'm going to, this is absolute time, 1.4 seconds from 10 o'clock. Okay, so it is 10:01.2, 10 o'clock and 1.2 seconds. So it sends that to the other PEs, and because it is clock sync, the other PEs, when they receive it, they're going to say, oh, we're going to take action exactly at that time, and we're going to switch our state. And for those VLANs that are getting impacted and we're going to lose ownership, I'm going to block those exactly at that time. So because of this clock synchronization, you can see how easy it is. And it basically, both the recovered PE as well as the existing PE can almost switch simultaneously. There is a little bit of skew time to make sure that, the existing PE, like a few milliseconds, you can put a few milliseconds time in there to make sure that existing PE go to the blocking mode few milliseconds ahead of the recovered or inserted PE. So that was for the time synchronization and stuff. Next steps, we need more discussions among interested party, finalize the new routes. As I mentioned, we already identified that we need to add the originating PE IP address inside the route. And the draft needs to be, we need to clarify that this approach is incremental and it goes on top of HRW. And the reason I like to make it incremental because I want to avoid too many permutations among all these different DF election mechanisms we have. Okay, I don't want this approach to work with the baseline approach, or this approach work with the HRW approach. It just, to me, doesn't make sense to have too many permutations. It just, we start from one point and we are improving the DF election gradually, and this is going to go on top of HRW. The sections on backward compatibility needs to get beefed up, and needs to also, for both approaches, needs to clearly spell out how the backward compatibility is done. It does that currently, but not quite to my likings. And I think also the comments that came up right now with respect to the loop, we need to clarify that there is no practically or typically there is no loop, and we are talking about duplication. So that's it on this one. Any questions? No? All right. Mr. Himanshu has a question. All right.
Himanshu from Siena. Do you really think this synchronization thing, I mean, the clock synchronization thing works? I mean, you can predictively determine when exactly you will switch over and all that stuff?
To a very large part, yes. And because they are clock synchronized, these leaf nodes inside the data center. And although you cannot do it at the microsecond, or let's say micro or pico level, but you can do it at the milliseconds. You can say within few milliseconds, this guy is going to do this.
Right, but I think
and that there is a big distinction between having this such a fast recovery within a few milliseconds of each other versus waiting for 3 seconds timeout.
Okay, I see. I'm having doubts on predicting the how long it will take to do the switchover and all that stuff. In the meantime, there's something else can happen, right? The one who has predicted that within 1.3 seconds I will switch over or take over this VLANs and stuff like that. So it's
well, you guys don't have non-maskable interrupt in your microcode?
It's not that. It's anyway. This is my comment.
All right, thanks.
Jeff, so this is sort of a comment to Manju. You can actually get better timing in many cases because you're synchronizing through a clock than you can on relying on BGP messaging order and queuing. So this will be better in many cases than just expecting BGP to get the messages to you in the right order at the right time through your TCP stack.
Yeah, if the DC is clock synchronized, frankly, this is a preferred way of going about it. Patrice, go ahead, please.
Yeah, Patrice from Cisco. Just to address Himanshu's comment, this is up and running in our lab, by the way. So please ask your engineers.
John Scudder. So I'm hoping you thought this through because I haven't. What happens if the guy who says in 3 seconds do blah, during those 3 seconds dies? So basically, how tolerant is this to multiple faults?
So if we look at it, this guy is gonna in let's say 1.3 seconds is gonna go and do the blocking. Okay, so let's say it sends a message, and then after that it dies. Frankly, nothing is gonna happen because the other P is gonna receive it, is gonna block the VLANs, and then after blocking the VLANs is gonna receive the ES route withdraw. Because as a result of that guy has failed, the ES route for that guy gets withdrawn. And it receives that and says, oh, now I need to, I know that it goes through another DF election mechanism. And it says, oh, you know what? Now I have to put these VLANs in the forwarding state because I lost that guy. So there's going to be an interruption to the traffic. There's not going to be a loop, but there's going to be a transient black holing as a result of that guy dying. Okay. Any other questions?
I do have 2 questions.
Go ahead.
Do you plan to recommend one of the approaches
The recommendation is if you have if your data center is clock synchronized, use the clock synchronized approach. If it is not, use the first approach, the handshake, because we cannot assume that all clock synchronization exists in all data centers.
Yeah, so why not specify just one mechanism, the one that would work all the time?
Because the clock synchronization is much. In other words, if your data center has such has a additional capability, why to shortchange your data center? So one mechanism that works all the time is a handshake. Okay, but if your data center has additional capability, let's take advantage of that additional capability and even do it better. And it is very simple approach, the clock synchronization.
Yeah, at the same time, it seems that like there may be some doubts on whether it can work well or not, right?
Well, I think if there is any doubt, then they should bring it to the mailing list and we make sure that those are being addressed, because the doubt that, well, John Scudder's comments got addressed, right? So that's not an issue. The other issue that Himanshu brought up with respect to, we cannot we cannot take action at a given time if the PE is not capable to do that, then I think there is an issue with the implementation.
Okay. The other question I have is, it would be interesting to have a delta with reference to what was presented on this topic in Dallas. So a draft was presented proposing a handshaking mechanism for essentially trying to address the same problem. So it would be interesting to have a short comparison, maybe.
Short what?
Comparison.
Short comparison?
Yeah.
Okay. True. The other draft, basically at that time, it was based on the RFC 7432, and it was talking about the handshake per EVI, which basically doesn't scale. So this one is, we are saying that, you know what, we're going to base it based on the HRW, and we're going to not have a handshake per EVI, but have a handshake per PE, regardless of number of EVIs that you have.
Thanks.
Sure, you're welcome. Okay, I guess if no more questions, we can go to the next. Himanshu, if you want, we can share our code with you. All right. Next draft. Virtual hub and spoke in BGP EVPN. This draft, okay. Little bit about the history of this draft. It got presented at IETF 94, November 2015. For this rev, we added Jeffrey Zhang as a co-author who contributed and wrote the multicast section of this draft. And we've changed the name of it to reflect that this is a Bess related draft. Where? Okay. Some background. If we look at the genesis of this draft, is mimics the draft that the hub and spoke draft for IPVPN, and the idea in here is data center, we already know how to scale the number of the routes or the number of IP routes or MAC addresses in the leaves by using default IP address or unknown MAC address. And by using that, basically, the leaf needs to only learn the MAC and IP addresses within their own data centers. They don't have to learn MAC and IP addresses from the remote data center because the gateways will be doing that. So as such, we improve the skills on the leaves. Here in this draft, we are saying that we can take that one step further and make sure that the leaves only learn the MAC and IP addresses for their own locally connected site, and they don't have to learn MAC and IP addresses from other leaves, even within their own data center. So you really improve their skill. And as I mentioned, this draft extends RFC 7024 for EVPN address family. And in the previous rev of the draft, it talked about the rules for generating and processing on unknown MAC addresses, unknown MAC routes, modifications that are needed for aliasing and split horizon and mass withdrawal, forwarding consideration for bridge mode and IRB mode, and the rules for ARP suppression. But what was not covered was the rules and procedures for broadcast and multicast traffic. And this rev of the draft addresses it. And the next few slides talks about that. So if you look at this figure, it talks about, you can see that there are a set of spoke, virtual spoke, VS1, VS2, VS3 associated with a set of VHubs, VH1 and VH2 in one cluster, and in another cluster we have vSpokes 4, 5, and 6 associated with VHubs 3 and 4. And the question in here is, okay, if the vSpoke 1 wants to send the multicast traffic, how does it get handled? And if you have IP tunnel versus MPLS tunnel, and with MPLS tunnel you use different multicast tunnel, whether it is ingress replication, RSVP-TE, or MLDP, it impacts the procedure, and the draft addresses it. So the idea is vSpoke sends only a single copy of the traffic to the VHub, and it gets from VHub, the traffic gets sent to the either point to multi-point tunnel or ingress replicated to the other vSpoke. And the stuff that one needs to watch out is, if it gets ingress replicated, you don't want to send it back to the same vSpoke that originated the traffic. And if it is going through a point to multi-point tunnel, you need to make sure that if it comes to the traffic comes back to the vSpoke that originated it, it gets discarded. And also the traffic gets properly replicated to the other cluster and to the other vSpoke. So all these salient points that I just talked about is what the this new section covers. So one of the as we mentioned that when vSpoke 1 sends a bump traffic to the VHub, we want to make sure that the traffic doesn't come back to itself, or if it comes back, it gets discarded, and that is called, a split horizon. And depending on whether we do ingress replication or we do point to multi-point, we do different things. If it is ingress replicated and if it is IP unicast tunnel is used, then you can use the IP source address to identify the originating VS, and as such, don't use that originating VS in your replication list. And if in case if MPLS tunnel is used for your MPLS unicast tunnel is used for your ingress replication, then we need to use a downstream assigned label that is assigned by the vHop to use it for the source identification. And if it is point to multi-point tunnel, we use upstream assigned label by VH1. These label we can distribute these label using PE distinguisher label attribute as both upstream and downstream assigned label, and it gets advertised along with the IMET route, and it is used to identify both the source PE as well as EVI and bridge domain. So it's not only used to identify the source PE, but also is used to identify the service instance. And as we for the route advertisement, just like any, there are a set of rules with respect to the route advertisement, that if the route's getting advertised by the hub, what kind of the route target to use, and if it is getting advertised by the spokes, what kind of the route target to use. For the spoke, when they advertise IMET route, for these bump traffic, the IMET routes gets advertised with the RT of EVI. So they are imported by all vHubs. And when IMET route gets advertised by the vHubs, they get sent with the RT of the vHub. And they are imported by associated VS spokes and vHubs. If a vHub uses MLDP point to multi-point tunnel, then it needs to the tunnel needs to get relayed. Not only the traffic needs to come to the spokes that are associated with this cluster, but it needs to go to the spokes of other cluster, and for that it needs to get relayed from one vHub to another vHub. And to do that relay, the SPMC AD route attribute is used by the vHub of the other cluster to set up the tunnel. And again, as we mentioned, when it goes from when the vHub in one cluster sends the traffic to the vHub of the other clusters, the vHubs in another cluster, only one of them needs to forward the traffic, and that's where the designated forwarder in a given cluster comes into picture. And we use a designated forwarding approach to pick one of the PEs or one of the vHub in that cluster. The draft talks about using a DF election, which is a bit different from the baseline DF election, and I need to have a chat on that, which I haven't got a chance to discuss that, if we can leverage the existing mechanism rather than using this new mechanism. Traffic forwarding rules is basically, there are a set of rules that specify in the draft, and it depends on the tunnel type, whether it is IP versus MPLS, and if it is MPLS, whether it is ingress replication or point-to-multipoint tunnel. And I'm not going to go through all those sort of rules. I think it is better to just you guys read that through. Next step, more discussion among the interested parties. Finalize the new routes. Actually, this is, let's see. There's a, more discussion and basically with respect to the couple of things for the DF election to, discuss whether the baseline approach can be used or whether we want to have a new approach. And pretty much, I think the draft is getting in a good shape, and maybe in by the next IETF, we're going to request for a working group call. Jorge, go ahead, please.
Jorge Rodan, okay. A couple of things. So the first one, so for IP tunnels, the procedures here are pretty much similar to the ones we have in the optimized ingress application draft. So my suggestion would be to leave this draft purely for MPLS procedures, and then it's good because you got different combinations that you need to address. But for IP tunnels, it's really ingress application.
No,
you go to the AR and then ingress application.
I don't have any problem with that. Frankly, the IP tunnel aspects of it that is mentioned in the draft is very small, very small. So we can basically point to the ingress replication if it is, unless it is different and it needs to be explicitly mentioned, and then we do that. Besides that, if it is the same procedure, then we're going to just refer to the assisted replication.
Yeah. Well, I think that would be good.
Yeah, sure.
The about the DF election, I mean, this is really something that you can actually, from each vSpoke, you can actually select any vHub, right? It's completely independent, and you can do this selection can be on a per.
This is not from the spoke to the hub. From a spoke, they can pick any one of them. This is from the vHub to vHub. When you go from one cluster to another cluster, and then your tunnel from this vHub, your multicast tunnel goes to the all the vHubs of another cluster, and one of those vHubs needs to be chosen to send the traffic to this associated spoke.
Okay. And that only happens when on the vHub you use MLDP.
MLDP.
Only in that case, right?
Correct. Correct.
Okay, so it's the DF election is really for one particular case.
Absolutely, yes. I think that is been stated in the draft. For the ingress replication, we don't use that. We don't use the DF election. Neither we use for point-to-multipoint using RSVPTE or BEER, just for MLDP.
Got it. And the last one, the draft says that the vSpokes, they also need to send the P distinguisher label attribute.
Right.
For a case, but I didn't get it.
Oh, it needs to send it for this split horizon filtering, such that when you use point-to-multipoint, okay, the point-to-multipoint traffic comes to all the spokes, okay? So the spoke that is originating a spoke needs to know that this is the same traffic that it has originated. And the PE PED label is for that, to identify that, hey, if you receive it and you're the originator, you can discard this traffic, and if not, forward it. So it is for a point-to-multipoint. For ingress replication, it is used. It is a for ingress replication is basically is a label to identify the originating spoke so that it can remove it from its replication list.
I understand the use of the label
Right.
when it is actually signaled by the VHOP, but if it is signaled by the vSpoke, how do you make sure it's unique? I mean, other vSpokes can actually have the same label, right? So in other words, I totally understand the split horizon.
So
mechanism
for the
with the-
VHub, if it is from the VHub, it is upstream assigned label, right? And if it is a upstream assigned label, that upstream assigned label is the same label that it is used for the downstream assigned
right,
to
right.
identify
But my
the
question is,
vSpoke.
who distributes the vSpokes labels, the VHOP or the vSpokes? I think it's the VHOP.
It is a VHub. I think Jeffrey wants to make a comment here as well.
Jeffrey from Juniper. So this PD distinguisher label attribute is originated by the spokes for the purpose of multi-homing across the, or not across, for the purpose of multi-homing. So even if you're using the ingress replication for the hubs to relay to the spokes, we're saying that to do split horizon for multi-homing purpose, the best way to do it is using local bias. So the spoke needs to know which source spoke the traffic is from, and for that purpose, the spoke need to
So
that.
Jeffrey, there is one for the there's a split horizon for the multi-homing, as you mentioned. Then another one to identify the source spoke.
Right.
That
right.
one
So,
is also a PED label, right?
right. So I think that's what Jorge was talking about. So if you're using the P20 tunnel to relay from the hub to the spoke, in that case, it's the hub that pick which label to
Pick the label, exactly. So in your case, to make the longest story short, for the question that you were asking is the VHOP is the one that assigns the label. If we bring into account another discussion of the multi-homing and a split horizon for the multi-homing purposes, then that label is assigned by the vSpoke. But I think let's differentiate between the two.
Okay, we can talk offline because in that case, I don't see it because in the local bias, you need to identify the source vSpoke.
Okay.
And if the if the vSpoke is the one allocating the label, can be some overlapping. So some other vSpoke can actually have the same label. So you don't really know if the traffic is
Oh, I
coming
guess,
from one of from that one.
Okay.
We can take it offline.
Okay, sure. You bet. All right. Any other questions? If no, thank you very much.
Can we have an idea of who has read this draft, please? Thank you.
Okay.
Next speaker is Jeffrey, please. Sorry, Martin's laptop has lost networking, so hold on.
So this draft, Wen Ling was going to present it, but she couldn't come here, so I'm presenting. This is updates, the version 3. Have 5 co-authors from Juniper, Nokia, and Cisco. So this draft was presented before, but we have included 6 important advanced topics in this revision. So first, I'm going to give it some background and the base solution covered in previous revisions, and then move on to the advanced topics. So inter-subnet multicast, if you put EVPN aside, the PIM is the de facto solution. And then when you bring in EVPN, it's similar. You can, without any changes, it can work. It's just not efficiently. So in this example, we have we have 2 subnets. Each subnet is a bridge domain or broadcast domain. The blue is one, the green is another subnet. We have 3 PEs here. In the draft, we actually used the word NVE. Well, we're mixing up the terminologies here. If you look at this picture, we have a source on the left side, and then we have receivers all over the places. So it just plain old PIM routing method plus EVPN is that in the source subnet itself, the traffic is switched, neutral switched to receivers everywhere. And then how do we reach the receivers in other subnets? Using PIM, well, another copy is routed to other subnets using integrated routing and bridging interface. In this case, PE3 is the PIN designated router for subnet 2, which is the green subnet here. And that copy is routed from subnet 1 to subnet 2 using the IRB interfaces, which are those 2 brown dots there. And once it gets routed into that subnet 2, and then the EVPN procedure kicks in. So the traffic is again layer 2 switched to all the receivers in that subnet 2, in that bridge domain 2. So while this works transparently, there are 2 problems with it. One is that you can see that the first packet is sent across the core in the original subnet, and then it's sent across a core again in the green subnet. So this happens for every subnet where you need to receive traffic. Another problem is that you notice that receiver 1 on the right side is receiving traffic from PE3, which in turn receives the traffic from PE1. So this is hairpinning problem that we also want to avoid. So optimized inter-subnet multicast, we call it OISM. The basic idea is that we make it EVPN aware. And the first one is still the same. In the source subnet, it's layer 2 switch everywhere. And then another copy is routed locally, independently to receivers in other subnets. And to do that, we don't even require PIM, or even if you run PIM, we don't care if you are the PIM DR or not. So in this case, PE1 routes to its local receivers in green subnets, P2 does the same, P3 does the same. And to do that, we also need to make sure that when you route the traffic down an IRB interface for a bridge domain, you do not send it across the core because other PEs already receive those traffic. The last point, I'm going to skip that for now. I just want to point out that in this solution, we don't even need to run pin here. It's just layer 3 multicast routing. So there are 6 important advanced topics we added in this revision 3. I'm going to talk about the first 3 here. In this picture, you notice that all the bridge domains or subnets are everywhere. But what if you don't have that situation? And then what about selective multicast? And also, how do you connect to external networks? I'm going to focus on the first 3, and the other 3 topics, they are in the spec. I'm not going to talk about here. So source subnet not in everywhere. If you again look at this picture, you can see that the source subnet, the blue subnet, is not on PE3. So how does PE3 get traffic? What we do is that we configure a supplemental bridge domain or broadcast domain. We call it SBD on all the PEs for that particular tenant. That SBD can either be VLAN based or it could be in a VLAN aware bundle. It has IRBs, but it does not have attachment circuits. Now, the magic happens here that traffic switched in the source subnet will reach all NVEs, all PEs, even if a PE does not have that source subnet present there. Once we make sure of that, and then in this example, the PE1 will switch traffic to PE3, but when traffic arrives on PE3, it's associated with that SBD. And then from there on is the local routing scheme, as what we talked about before. In this blue, for PE2, because the blue subnet is presented there, so the traffic will be associated with the source subnet itself. So how does this magic happen? It's the tricks we play with the routes. In the inclusive tunnel case, we're talking about the IMAD routes. I'm going to use the ingress replication example. There are some other tunnel types. They are all covered in the spec. Let's go back to this picture here. So we have this blue SBD configured everywhere, and then every PE will advertise the IMAD routes for that SBD. That route carries the route target that will allow it to be imported on all the PEs. Now, when PE1 builds its forwarding states used to switch traffic in the blue subnet, it's going to look at all the IMAD routes in that SBD. It's no longer looking at the IMAD routes in the original source subnet. It's look at the IMAD routes in the SBD. That way, it knows all the NVEs, all the PEs that need to receive the traffic. Then, let's say it noticed that PE2 needs to receive traffic. So, and it also noticed that PE2 also originated the IMAD route for the blue subnet itself. So it's going to use the label for that blue subnet itself. Now, when it looks at PE3 that needs to receive traffic, you notice that I only have IMAD route for this SBD, but I don't have IMAD route for the source subnet itself. Therefore, I'm going to use the label in the IMAD route for the SBD. Because of that, when the traffic arrives at PE3, it will be associated with the red SBD. So that's the magic we play here. MLDB tunnel also plays some tricks there. That's how it works. I'll leave the details here for now. Selective multicast. In that IGMP MLD proxy drafts, it was talked about that selective multicast Ethernet attack routes are used to tell which PEs need to receive traffic. And for other tunnel types, we also need to add in the SPNG routes to announce the tunnel to use. Now, to integrate with intersub multicast, what happens here is that if a PE has local SG or star G IGMP states, here we will proxy those states from tenants, the BDs, into this special SBD. That will trigger, what may trigger corresponding SG or star G SML route into this SBD. Now, notice that if you do not have any tenant routers connecting to those tenant BDs, in that case, we no longer need the SML routes in the tenant BDs anymore. We only need it in the SBD. Again, using the ingress replication example, the source PEs will build a selective tunnel using to send to the layer 2 switch in the source subnets. For that, he needs to know which MVEs, which PEs need to receive the traffic. Again, it goes through the corresponding SML route in the SBD. If he sees a SML route from that MVE, from that PE, he needs to include that into ingress replication tunnel. Now, again, the next question is, what label do you use? It's similar to the ingress to the previous inclusive tunnel case. If you have an ML route for the source subnet itself, using the label from that route. If you don't, then use the label from the SBD ML routes. Other than that, everything is the same. And other tunnel types are talked about in the spec as well. Connecting to external world, here I have a picture with four MVEs. Again, I'm mixing the P's and V's somehow. I didn't have this. The spec all use MVE term. So here I'm somehow got mixed up. Anyway, all those the 4 square boxes are MVEs, and the 2 top ones I gave them a name, multicast gateways. So they connect the EVPN subnets to external world. The external world could be run in PIM or MVPN. Now on those quick gateways, that red SBD are always present, and those gateways could also have some tenant broadcast domains present there. So the gateways will have IRBs for all those SBD and tenant BDs, and they also run PIM there. So here, the gateways will behave as PIM first hop routers and last hop routers to the PIM or MVPN domain. And so if inside of the EVPN there are receivers, then the gateway will send joins, or in case of MVPN connection, it will send MVPN simulcast routes towards external sources or external RPs. And if you have sources inside the EVPN for any source multicast groups, then one of the gateways will also be responsible for sending PIM register messages to the external RPs. There's some description on how the traffic forwarding work. I'll go back to this picture. Let's say there is a receiver connected to NVE2 on the lower right corner. So the SBD routes will be, no, SMAN routes will be originated in the SBD, and one of the gateways will send the corresponding pin joins towards the external RP or external source. That will put traffic down to the gateway, and then the gateway will route the traffic into the EVPN, the bridge domains. If the receivers are connected to the gateways directly, then they will be routed by those gateways in those corresponding bridge domains. Now, if the receiver is on a remote NVE1 or NVE2, then the traffic will have to be routed through that special red SBD. Here, traffic routed on IRB interface, we mentioned earlier that they would not be sent across the core, but here the SBD is special. They will be routed across the core. That's the important thing here. Now, again, if there is a source connected to NVE1, and there is a receiver out there in the PIM or even MVPN domain, then and the traffic is for any source multicast group, what happens is that one of the gateways is going to be the PIM DR, and it will send PIM register messages to the external RP. And after the PIM register messages, one of the things is going to happen. Either a PIM register stop will come because nobody is interested in receiving the traffic, or a source join is going to be received by one of the gateways. And because of that, then the gateway will either send the SMAN routes, will send the SMAN route to either pull or prune traffic from the source. So I skipped those three topics that was outlined in the slide, but they are in the spec. So we're here, we need to seek and address comments from the working groups, and we also need to update the procedures for interrupt situation where you could have some routers, PEs that do not support this optimization at all. What do we do? We have some ideas. We need to some further discussions among the authors here. We have, and also, yeah, connecting tenant routers. We need to add or update some details. Assisted replication, we need to add more text there. After we take care of those things, then we'll seek adoption. Questions?
Hi, this is Ashutosh from Cisco. I read your three versions actually, and I see the approach has changed quite a bit from the first version, which is very good. It has a lot of optimizations from the first version. One question I have is, when you describe these tunnels which are created from NVEs, are you describing these are the bump tunnels?
Yes, bump tunnels, yes.
Okay. So that would mean that all the NVs in the overlay would be listening to the bump tunnels of all the bridge domains existing in the network. Whereas today they would listen to bump tunnels, or they will receive traffic from the bump tunnels only, which are configured on that VTEPs or NVs. Is that correct?
In case of the ingress replication, we only need to advertise the IMAP route for that SBD, and indeed all the NVEs for a particular tenant will need to import those routes. And if you have you're using P2MP tunnels, I didn't talk about those details here, but since you asked, I'll point out that if a tenant has let's say a tenant has two bridge domains, and then all the MVEs for their tenant will need to listen to all those IMAP routes for those two bridge domains. Yes.
Yeah, but not just the IMET routes. I mean, there is a broadcast and non-unicast and multicast traffic which is put to these dump tunnels from all the NVs, and it will reach all the endpoints, whether they have that particular bridge domain configured locally or not. Do you see it as a potential issue, especially a lot of control packets being flooded in the bridge domain, meant to be reached to only Ps or VTEPs which have that bridge domain?
I see your point. Yes, indeed. I should clarify. It's not. Now I see. It's not it's not the default PAM tunnel. It's really just. It's really. We could call it a star SPNZ tunnel that is used for multicast traffic addressed to beyond the 224.0.0/24 range.
Okay.
Right. Yeah.
Okay. So in that case, you will have 2 tunnels per bridge domain from each PE.
Right.
Okay. So that's a lot of new tunnels. Okay. I have an additional comment that you did not mention any distributed anycast gateway interop with your solution, which is a very prevalent technology used in data centers today to enable mobility, right? So it wasn't mentioned in the draft, and did you think about it?
Distributed gateway.
Distributed anycast gateway?
Anycast gateway. I think that's so. In the unicast case, when you where each MVE is a great gateway for intersummer traffic, that model still exists here. It is still the distributed gateway model. But if you don't do anything, when it comes to multicasts, even though you are using distributed model for unicast, the multicast routing is still sort of centralized because you have to go through the PIM-DR. With this optimization, now it's again distributed, even for multicast. But the anycast aspect of that thing is irrelevant here because the multicast it does not require the MAC address or IP address of the router itself, right? So.
Yeah, but the underlying unicast, if it is implementing distributed anycast gateway, then how would this approach work?
It does not change. It's still the same.
What I meant was that in that case, all the IRB interfaces on particular BD has the same IP address. How would you elect a DR? Because your approach mentions learning about a DR and doing specific procedures on the DR.
Inside the EVMP itself, you actually do not need to run PIM. So in this example, on NVE1 and NVE2, you do not need to run PIM. On the gateways, you do need to run PIM. But again, even if you're using the anycast gateway for the unicast purpose, you can still have additional IP addresses configured on the IRB interfaces, and you can use those addresses for PIM purpose. So that way, gateway 1 and gateway 2, they can talk to each other using PIM, using their own address.
Okay, so that wasn't clear from the draft that you are proposing to have an additional IP address configured on the IRB interfaces.
I think in the older versions, we should have had added it, but if not, I will make sure I'll clarify it. Yeah.
Okay. And like you mentioned, you are interoperating with MVPN. The problem within the data center also looks very much alike a problem which MVPN can solve. You're trying to do routing within different bridge domains. Did you happen to think about, was there a discussion where you could use MVPN? Because at Cisco, we thought about it, and this problem was when we came up we had already an MVPN implementation, and it was a very small work to do to make it work in EVPN multicast routing. Whereas in your draft, I see it's a lot of work, a lot of additional work needs to be done if you do this approach.
Well, in the very first version, we actually said that if a subnet is not present anywhere, then we would use MVPN to pull traffic from one PE to another PE. We actually moved away from the model because several reasons. One, the most important reason is actually that if you use MVPN, then your intra-subnet traffic actually goes through two routing hubs. That has at least two implications that we do not want. One is that TTL gets decreased twice. The second one is that your source MAC address changes. A changed source MAC address when the traffic is still inside the same subnet, that may or may not be that important for some applications, but decremented TTL may be really bad for some applications. So that's the most important reason why we do not want to use MVPN. Another reason for not using MVPN is the split horizon in the source subnets. And then putting that aside, using MVPN in the EVPN itself has more complications that we really do not need, especially if you are just using the EVPN to connect your VM host together, where you can see that you do not really need PIM. You do really all those things. If you introduce MVPN, there will be a lot more complications get pulled in. So
for the point, we did it, and we should talk.
Yeah, we should talk. Yes. Yeah.
The last comment I have is that one of places in your draft you mentioned that if you have a shared tree join, it means you're trying to pull traffic on a star G. You would like to program all the possible BDs as an incoming interface. That seemed a little bit odd to me because I did not understand how would you program more than one RPF interface for a star G.
For star G, because the traffic could be coming on many subnets, so you have to list all the possible IRB interface there. When you do layer 3 multicast routing, you have to take care of the expected incoming interfaces. So that's why we needed it.
I just want to say about the remark that wouldn't it be easier to just use MVPN? I think that really is not a well-defined statement, even what that means. There are dozens of issues, and I've been asking for some other people to say that I have submitted a proposal for months, and some other proposal never gets done. And frankly, I don't think there's much credibility to the claim that you did it easily and it's already working. Yes, but the devil is in the details, right? There's all kinds of things in the MVM VPN code that don't apply to the EVPN environment. People think the determination of the upstream multicast up and expects attributes beyond the attributes and then there's the layer 2 specific stuff, which MVPN has no notion of, like multi-homing. In fact, there's quite a few things to work out here. Now, what's really in this proposal is an adaptation of the MVPN procedures to the EVPN environment. So it's possible that there's a simpler solution, but if you compare a solution that has all the details worked out with just a solution that expresses one sentence, it's always going to see same simpler.
Any other questions, comments?
Okay, thank you. Next speaker is still you, Jeffrey. No, sorry, it's Yizong. Yizong.
Hello, everyone. This is Yisung Liu from Huawei. The draft about the MVP Yang model from the multicast Yang design team. This is the version 3 for the MVP Yang model, but it's the first time to presentation. The MVP Yang model structure according to augment the L3 VPN Yang model, and it's from the Huawei, Epson, Cisco, and Juniper. For the global structure, it's augment the L3 VPN Yang model. Under the IPv6, IPv4, and IPv6, we augment the MVPN here, and we separated the MVP instance for IPv6 and IPv4. For the root target, because the MVP root has his own AD root and the semantic root, so we can configure own root target. But here we just follow the L3 VPN Yang model. As I know, the IETF root types draft has defined the common types of the root target, so we will fix that in the later version. This is the IPMSI tunnel configuration based on the RFC 6513. The tunnel type, we have the 7 types here. For the IPMSI tunnel configuration, as I mentioned here, for the group and the source address range in the private network, we have 2 choices to configure the range. One is the address mask, and another is ACL. And in the address mask configuration type, we can just configure the wildcard address, both in the source address and the group address. And to follow the slide, show the IPMS tunnel and the SPMS tunnel operation state. Now for the IPMS tunnel, we can show the reference SG who use the IPMS tunnel, and it will show here for every SD running on this tunnel. The same definition for the SPMSI tunnel. Yeah. So in the next step, we wanted to for the WG adoption, and we welcome to welcome more vendors or carriers involved the draft, and need more comments. Any questions?
Can I have an idea of who has read the draft? Okay. Thank you.
Thank you very much.
Yeah, my friend, thank you.
All right, so this presentation is about the BGP signal multicast, co-authors from Juniper, Arcus, Cisco, and Thomson Reuters. So why we want to do this? Many operators, especially some data center operators, they don't want to burden their infrastructure with multicast trees for many reasons. So they could live with ingress replication, or they don't like the some aspects of the multicast trees. For example, per tree state, in case PIM, you have soft state refresh, and in case of any source multicast, the complexity that comes with the shared tree to source tree switch. And even if you put all that aside, someone may say, yes, it's yet another protocol I need to run. I just want to run BGP. There have been many data center operators who want to do that. So again, to some operators, it's very important for them to be able to do multicast trees in their infrastructure so that they can do forward traffic efficiently. And before beer can do can be deployed, this is a realistic problem for us to solve. So what is BGP signal multicast? Basically, we can use BGP to replace PIM signaling, or you can replace it, the MLDP signaling. And in the MLDP replacement case, we just use the MLDP flag to identify the tree. In the PIM case, we could use BGP to set up the SG or star G trees, whether it's unidirectional or bidirectional. And optionally, we can use MPLS data planes. Again, if we do this, we can remove the PIM complexities and soft states. There have been attempts before to address those problems. PIM reliable transportation, it does remove soft states, but somehow the deployment has been limited. And PIM SSN, it requires good source discovery methods. And this proposal here with BGP signaling does provide a very good source discovery solution here. And again, with this, we can consolidate to BGP signaling so that a single scalable protocol can be used for unicast, multicast, labeled, or unlabeled. How do we do it? It does not change from the PIM or MLDP paradigm when it comes to tree setup itself. It's still receiver-initiated joints. Here we are using leaf AD routes in C multicast SAFI. Those routes are propagated hop by hop over eBGP or iBGP sessions, or they can be through via route reflectors. Each node will determine the upstream hop using the same procedures that PIM uses or MLDP uses. Now, if you are setting up the SG or SRG trees, the leaf AD routes will serve the purpose of PIM join. And if you're using setting up tunnels like MLDP tunnels, then the leaf AD routes will serve the label mapping purpose. And the routes, the NRI will encode the SG information, StarG information, or MLDP FAC. The routes will carry a route target to identify the upstream router, so that only that upstream router will process it and then terminate that message. It's not further propagated. If the tree, if you're not a tree yet, so you still need to, you will then originate new leaf AD routes with new NRIs to send it to upstream. If you're using MPLS data plane, then you need to signal label for that, we use the tunnel encapsulation attributes. And if the upstream downstream is not directly connected, even if you do not use the NPLS data plane, you still need to signal the tunnel information to get the traffic through. So for that, we also use the tunnel encapsulation attributes. And then again, when it comes to any source multicast, how do we find out the sources? We're going to use source active AD routes to distribute the source information. With that, we do not need to use the shared tree anymore and avoid the complexity that comes with shared tree and source trees interaction. So I'm going to skip most of the details here, but I want to mention, talk about why do we want to use BGP to signal MLDP tunnels. Actually, you can, this is that, so that the entire or just part of MLDP tunnel can be signaled by BGP. Imagine that you have an existing MDP deployment. Everything is all set. You use for example, use BGP MVPN with MLDP tunnels. Everything is all set using MLDP signaling. But now you want to swap out MLDP signaling underneath. Then you can change it to BGP without changing anything else. So so with that, we can just encode MLDP tunnels in the BGP NRRI. So exactly how the messages are encoded and processed, I'm going to give those details. Now, coming to PIM, any PIM replacements for any source multicast. Basically, the first hop routers, they will advertise the sources when they receive the traffic from the source. The last hop routers will receive those, and then they will join the trees, source specific trees. That's very high level. So how do we do that efficiently without flooding it? Because this is very similar to MSDP, except MSDP was mainly among the RPs. Now we're extending it from the first hop router to last hop routers. And more importantly, we are using the BGP mechanism to make it more efficient. With original MSDP, you have periodical refreshing. Even though it uses TCP, but MSDP still has periodical refreshing. And MLSDP, we use RPF checks when we propagate the SA routes. With BGP, none of those happens. And we can use the route reflector and route target constraint mechanism to avoid flooding. Just imagine this very simple network where you have one route reflector with all your routers running the BGP signal multicast. The first hop routers only need to send the source active routes to the route reflector itself, and then the route can stay there. That route will carry a route target. The route target will encode the multicast groups that SA route is for, and then the route can stay on the route reflector. Nothing happens until the last hop routers get the IGP join for group. At that time, the last hop router will send route target membership NRI to the route reflector. That NRI will encode the group that it is interested in. Once that happens, the BGP mechanism for route target constraint will kick in, will send the source active routes to the interested last hop router. So that's the advantage of BGP mechanisms here. And even though I use a single route reflector in the example, you can have a whole bunch of route reflectors working together on this. And now, transition is very simple. If we are talking about MLD replacement or PIM SSM replacement, the transition can happen independently on any nodes. You can, if you support this BGP signaling and your upstream router support the signal support the same, between you and your upstream, you can do the BGP signaling. Well, nothing else changes. Now, if you have PIM ASM replacement, you can upgrade your rendezvous points so that guy can support BGP signaling, and so that it can originate source active routes based on the sources it learns through the PIM registering mechanism. After that, any node can transition independently. If you are a transit router and you get a PIM *G join from your downstream, you just behave as if that's an IGMP join. You don't send the *G join towards the RP. You wait until you should receive the source active routes. So with that, the transition is very straightforward, and it can be incremental. So as far as the spec is concerned, we need to add more details. For example, what if the neighbors are not directly connected? We talked about that using tunnels, advertising the tunnel encapsulation attributes, but more details need to be added there. And so we do have customer interest in this, so we are working together on that, on the spec, and also trying to get more comments from the community here to see where we go. Thanks.
Robert Rashwood. So Jeffrey, one comment. I think this is extremely useful and nice work. One question is, have you considered to use, instead of the current proposal for data plane, segment routing MPLS, especially the segment routing spray functionality, to really simplify even more the data plane? The BGP part procedures here, I think, should be exactly the same.
Well, when you talk about unicast segment routing, the transit routers do not need to maintain any state. When it comes to multicast, if you don't want to maintain per tunnel per tree state, only solution so far I'm aware of is BEER. This solution cannot really address data plane problem. It's
No, but this is very topology dependent, right? If I have spines and I want to efficiently replicate at spines, spray is very good tool.
Yeah, but you will still have per tree or per tunnel state. I think that's unfortunately the reality before you can have BEER. Right? It's just the signaling of those trees or tunnels are simplified or consolidated using a single protocol. Okay, thank you.
Are there any other comments? I'm surprised. And we have 10 minutes. I see Lenny over there. You're Embody co-chair, right? Would you have something to say? I mean, obviously, this draft is a bit beyond the strict charter of Bess, I believe, because it's tackling a non-VPN use case, even though it's really reusing VPN procedures. So I believe that some coordination, perhaps not coordination, but some discussion will need to happen also with PIM crowd, probably Embody, but well.
Yeah, I would agree with that. I think just guessing, it looks like this working group is probably the best place for it because it's BGP. MBOND, we would love to contribute and comment as as an operations group. But really PIM is evolving into the multicast routing protocol working group. So this kind of fits into a little bit of both PIM and Bess's bucket, probably more so Bess than PIM. I see that, I believe this is scheduled for, to be discussed tomorrow in PIM, which makes a lot of sense. And MBOND holds our meetings jointly with them. So I think we'll get good representation on this.
Okay, thank you. Okay, looks like we're done. Did everyone sign the blue sheets? Sorry.
Well, they were sent here.
Sorry, where are the blue sheets, please? So who didn't sign? So whoever didn't sign can come and sign here.